Hello everyone. Today we are going to discuss 12th class physics. If we will see this 12th class physics, it is mainly divided in three parts: electromagnetism, optics and modern physics. So if we will look at this electromagnetism, again it is divided in two parts: electrostatics and electrodynamics. In the electrostatics, charge in rest condition, and in electrodynamics, charge in moving condition. Then next part is optics. In the optics we have two chapters, ray optics and wave optics. This both chapters we will read under this optics part. Now the next part is modern physics. In the modern physics we have total four chapters: dual nature of matter and radiation, atom, nuclei and semiconductor. This all four chapters we will read under this modern physics, everyone. So if you will look this first part, everyone, electromagnetism. So electromagnetism is divided in two parts: electrostatics and in electrodynamics. This thing already we knows. In the electrostatics, charge in rest condition, correct, and in electrodynamics, charge in motion condition. So in the 12th physics, first two chapter will come under this electrostatics part, everyone. So electric charge and field chapter and electric potential and capacitance, this both chapter we will read under this electrostatics. And current, electricity, magnetic effect of current, electromagnetic induction, alternating current and electromagnetic waves. This all five chapters we will read under the electrodynamics, because in this all five chapters charge in moving condition. So I hope this thing is clear to you, how we are dividing this 12th class physics. Now we will discuss first chapter from 12th class, electric charge and field. So in this first chapter, first of all, we will discuss about properties of charge. So if you will look first property, everyone, like charge repel each other. So like we have two positive charge, and if you will put this two positive charge, so they will repel to each other. Similarly, if we will take two negative charge and if we will put at some distance, so again they will repel to each other. So like charges repel each other if we have positive or we have negative charge. Second property is unlike charges attract each other. Unlike charges means if we have one is positive and second is negative charge. So if we will put one positive and negative charge at some distance, so they will attract to each other. Now the third property is charge is a scalar quantity and additive in the nature. So charge is the scalar quantity, everyone, and it is additive in the nature. Like if we have 1 coulomb charge plus 2 coulomb charge minus 2 coulomb charge, and if you want a net charge in the system, so as a scalar we can add this all the charge and we will get net charge present in the system, correct? So it has additive nature and it is a scalar quantity. So this is the third property. Now the fourth property is conservation of charge. Charge is conserved, everyone. So for an isolated system, net charge remain the constant. So what is the sense of this conservation of charge and charge will remain the constant? Let's see it, everyone. Let's suppose we have one isolated system. So system should be isolated, and in this isolated system we have, let's suppose, plus 2 coulomb charge. So whatever process we will do inside the system, net charge will remain the same. It is plus 2 coulomb only, whatever process we will do it, because net charge for the isolated system will remain the same and charge is always conserved. So this is the property number 4, everyone. So now we know total 4 property. First is like charges repel each other, unlike charges attract each other, like positive negative attract and positive will repel to each other. Third property is charge is the scalar quantity and additive in nature. Now the fourth property is charge is conserved, correct? If we have an isolated system, so whatever process we will do it inside the system, net charge will remain the same. This is the fourth number property. Let's see next property, everyone, charge quantization. So what is the next property? Charge quantization is the principle that the charge of any object is an integer multiple of the elementary charge. So charge quantization is the principle that the charge present on any object is the integer multiple of the elementary charge. So if we will look at value of the elementary charge, so it is equal to 1.6 into 10 raised to minus 19 coulomb. So this is the minimum value, correct? So this much charge we can remove or add on the body. This much minimum charge we can add or we can remove from the body. So if suppose we have one body, everyone, and we want to put plus 1 coulomb charge on this body. So how many number of electron we need to remove from the body? This thing we want to find out. So remember this thing, everyone, always we are transferring electron or we are removing electron only, not a positive charge, correct? So only we are removing or adding electron, correct? So we want plus 1 coulomb charge on this body, then how many number of electron we need to remove? This thing we want to determine here. How many number of electron we need to remove from this body? So from the charge quantization principle, we know that Q equal to NE, correct? This thing we know that from the charge quantization principle, Q equal to NE. So here we want plus 1 coulomb charge on this body, then how many number of electron we need to remove? This thing we are finding. So N equal to what it is, Q by E from the charge quantization. We want here 1 coulomb charge, everyone, and E value is what it is, the 1.6 into 10 raised to minus 19. So the value of E is what is 1.6 into 10 raised to minus 19. Now simplify this, then how much you will get? 6.25 into 10 raised to 18, correct? So this much electron we need to remove from this body. If this much electron, if we will remove from this body, then this body will get plus 1 coulomb charge. If you want to put minus 1 coulomb charge, then this much electron we need to transfer on the body, then this body will get minus 1 coulomb charge. So I hope this thing is clear to you, everyone, what is the charge quantization, and from the charge quantization principle we can write here Q equal to NE, and E is what? It is the elementary charge. It is the minimum charge which we can transfer or we can remove from the body, correct? And the value of E is what? It is 1.6 into 10 raised to minus 19 coulomb. Now we will do it comparison between charge and mass. So let's say it first point, everyone. Charge cannot exist without mass. Mass can exist with zero net charge. So what is the sense of this point, everyone? Charge cannot exist without mass. So if charge is present, so there should be the mass always. Like if we will see it, charge present on the electron, so it is 1.6 into 10 raised to minus 19 coulomb. This is the charge present on the one electron. And what is the mass of the electron? It is 9.1 into 10 raised to minus 31 kg, correct? So if charge is present, so there should be the mass, correct? This thing will happen always. Now if you will see this point, mass can exist with net zero charge. So if you will see it one body, everyone, and let's suppose on this body negative charge and positive charge both are equal, correct? Number of electron and number of proton present on the body is equal, then what is the net charge? Then the net charge is 0. If number of positive charge and number of negative charge both are equal, then the net charge on the body is what? Is 0. But mass is not 0 here. So this thing is possible. Net charge is 0, but mass is not 0, correct? So I hope this first point is clear to everyone. Let's see it. Next point, everyone. The magnitude of charge is independent of its speed. So magnitude of charge is not depending on the speed. If you will vary the speed of the particle, then the magnitude of charge will remain the same. Now if we will see it relation between the mass and the speed, so we have the magnitude of mass is depend on the speed. So if we will vary speed of the particle, then the magnitude of the mass will vary, everyone, and this thing we will find with the help of this formula from the relativity. So from the relativity we have one formula, m equal to m naught root 1 minus v by c whole square, correct? So how this formula is establishing relation between the mass and the speed, let's see it, everyone. Let's suppose we have one particle that particle has m naught mass initially. M naught is the rest mass of the particle, and now this particle is moving with speed of light. So when this particle is moving with the speed of the light, so we have v equal to c. Here v is what? V is here speed of the particle, and c is the speed of the light. Right now this particle is moving with the speed of the light, that's why v equal to c we have. So now the next thing is what? M equal to m naught. M naught is the rest mass of the particle, 1 minus v by c. So v by c, so c by c. Now c and c will cancel out, then it is 1, and 1 minus 1 is 0. Then we have m equal to infinite. Correct? So if the speed of the particle is equal to the speed of light, then mass is infinite, everyone. And if the mass is infinite, and then we have required infinite energy for the acceleration of the particle. So if we want to accelerate the particle, so for the acceleration we have required infinite energy. Correct? Which is not possible. Correct? So which is not possible. So we are getting equal to infinite if m equal to infinite, if you want to accelerate the particle. So I hope this point is clear to you. Correct? So mass, so the speed of the particle cannot be equal to the speed of the light, because when the speed of the particle is equal to the speed of light, in that case we have required infinite energy for acceleration of the particle, which is not possible. And this thing we are getting from the relativity, and this formula is given by the Einstein. Now the next point is point number 3, everyone, charge quantization. Correct? Charge quantized. So we know that charge is quantized. About this already we know that charge is always quantized. Correct? But mass is not quantized, everyone. So the quantization of the mass is yet to be established. So this is the point number 3. Charge is quantized, but mass is not quantized, everyone. Now the 4th point is the force between charge can be attractive or repulsive. Like we have two positive charge, so we know that between the positive charge we have repulsive force. But if we have positive and negative charge, then what will happen between this? We know that they will attract to each other. Correct? So they can attract and they can repel also. Alright. Now the 4th point is the gravitational force between two masses is always attractive. So if we will see charges, so charge can attract to each other and they can repel also, but this thing will not happen to the mass. If we have a mass, everyone, so mass is always attract to each other. So if we have a mass, so mass we will put at some distance, so they will attract always each other. And between the masses we have gravitational force. Correct? So mass is always attractive, everyone, but charge can be repulsive and it can be attractive also. Both things is possible here. So this is the comparison between the charge and the mass. So I hope this all 4 points are clear to everyone. Now next we will discuss about the method of charging. So let's see it. First method, everyone, charging by rubbing and friction. So when insulated material rub against each other, they may become electrically charged. So if we have insulated material, like we have one plastic rod and we have one silk cloth. So let's see this example, everyone. In this example, we have one plastic rod and we have silk cloth. These both are insulated, correct? And we want to do it charging here. So what we will do it here, we will take this rod and we will do it rubbing with a cloth, correct? So like this is a plastic rod and this is silk cloth. So if I am doing the rubbing between these two, so what will happen here? Let's see it, everyone. Initially on this rod, positive and negative charge are equal. Correct? So initially on the silk cloth, positive and negative charge are equal, and on the rod also. But when we are doing rubbing, so what will happen? Electron will transfer from the rod to the silk cloth. This thing will happen because affinity of the silk cloth toward the electron is greater. Correct? So affinity is greater, that's why it is attracting to the electron. So now what will happen here? On the silk cloth we have greater number of electron. So net charge on this silk cloth is becoming negative. And here when we are doing rubbing, so some electron is transferring from rod to the silk cloth. So right now on the rod we have excess number of positive charge. So net charge on the rod is positive and the net charge on the silk cloth is negative here. This thing will happen. So I hope this method is clear to you. Let's see next method everyone, charging by the conduction. So in the charging by conduction we have required two conductors. So let's suppose we have two conductors. Conductor A and conductor B. And let's suppose initially this conductor A is neutral. So neutral means is what, net charge is zero. So positive and negative charge is present, but initially net charge on the body is zero. This is sense of neutral. Correct. And we have second body, and on the second body we have positive charge. Means on the second body we have excess number of positive charge. So now we are doing charging by the conduction. So in the charging by the conduction method, we have required physical contact between two conductors. So we will make physical contact between these two conductors. What will happen? We will make physical contact between these two. Then let's see what will happen. On the body A, we have positive and negative charge are equal. And on the positive, we have excess number of positive charge. Correct? So body B will attract negative charge. Correct? So electron will transfer everyone from A to B. So electron is transferring, negative charge is transferring from A to B. Now what is happening here? Some electron is transferring from A to B. Correct? And now on the A we have less number of electron. So now on the body A we have deficiency of the electron because electron is transferring from A to B. So on the body A we have deficiency of the electron, everyone. Because negative charge is transferring from A to B. So on the A we have deficiency of the electron. So then what is happening here? Now body A is becoming positively charged. So initially it is neutral, but when we are making contact between A and B, so here what is happening, electron is transferring from A to B, and now this A is becoming positively charged because now on this body A we have deficiency of the electron. So this is the charging by the conduction method, everyone. So I hope this method is clear to you. Now let's see third method, everyone, charging by the induction. In the charging by the induction, here physical contact between the body is not required, everyone. But in the conduction method, we have required physical contact between the two conductors. This is the difference between the conduction and the induction method. So let's see it first method, everyone. Here we have two methods, one by one we will discuss. So first of all, we will discuss method one. So what we are doing in the method one, we are taking initially three conductors. So conductor A, B and C. So on the conductor A we have positive charge. Correct? And B and C initially neutral. And on the conductor A we have positive charge. So when we are putting conductor A near to the B and C, so between the electron and the positive charge we have attractive force. That's why all the electron will come on this B part. So on the B part we have excess number of electron. and this thing is happening due to the attraction. So electron is moving due to the attraction from C to B. So on the B part we have excess number of electrons, that's why this B part is negatively charged, and on the C part we have deficiency of the electron, that's why C part is positively charged. So B part is negatively charged, C part is positively charged. Now separate this both the part, everyone. So now do it separation between this both the part. So if we will do it separation between this both, so on the C part we have positive charge and on the B part we have negative charge. So this is a charging by the induction, everyone, and this is the method number 1. Let's see second method, everyone, method number 2. In the second method we have required 2 conductor. And we are putting this conductor on insulated stand, everyone. So this is the insulated stand. On conductor A we have positive charge, and conductor B is initially neutral, everyone. Means positive and negative charge are equal. So initially B is neutral, everyone, means net charge is 0, means positive and negative charge is equal. So what will happen on this A charge, on the A body we have positive charge. So between the positive and negative we have attraction. So all negative charge accumulate over here. And this thing is happening due to the attraction, everyone. So this part has negative charge, and on the right part, on the right side we have excess number of positive charge. So this part is positively charged, everyone. Correct? So due to this induction, what is happening here? Separation of this negative and positive charge is happening. Now we will take one wire and we will connect with the earth. So take one wire, everyone, and connect with the earth. So if we will connect this wire with this B body, everyone, so what this earth will do it, because on this right side part we have positive charge, correct? So electron will move from earth to this right side part, correct? So electron is moving from earth to this positive side part. So right now this part is becoming neutral, everyone. So when we are doing earthing, then what is happening? Earth is sending some charge and earth is making this part is neutral, everyone. Correct? So now this part is neutral, and on the left side part we have negative charge. Now the next what we will do it here, we will separate this earthing. Correct? Now what we will do it, we will remove this earthing and we will remove this A body also. So now here we have only B body and it is isolated, correct? Because A we are removing and we are removing this earth also. So now we have only B body. So already this right side part is neutral, everyone. Only on the left side we have negative charge, correct? So when we will remove this earthing and when we will remove this A body, everyone, so this negative charge will spread on the B part. Now this negative charge spread all over this B body. Now this B body is becoming negatively charged. So this is the method number 2, everyone. And by the earthing also we can do it charge, correct? We can do it charging. So I hope this method is clear to everyone. So now next we will discuss about gold leaf electroscope. So what is the gold leaf electroscope? Gold leaf electroscope is sensitive electroscope type that is used to detect the charge. So with the help of this gold leaf electroscope we can detect charge. These are the main uses of this gold leaf electroscope. Now we will see it main component present in this gold leaf electroscope. So here you can see it in the top we have brass disc, correct? Then this is the insulator plug. Then this is glass case, or we can say that glass jar also. And this is the brass rod, and this is gold leaf here. This is gold leaf, and at the bottom we have here metal foil, and we are connecting this metal foil with the earth, everyone. So we are doing here earthing also. So why we are doing here earthing, why we are putting here metal foil? Because if some charge will fall from the here, so due to this foil, what will happen? This charge will go in the earth. Otherwise, what will happen when you will touch this this electroscope, then you will feel some electric shock, correct? So here, if you will do it, if you will do it here earthing, then what will happen? This electron will fall, correct, on the bottom of the case, then it will pass from here to the earth. So this earthing is necessary, everyone, correct? Otherwise you will feel here electric shock when you will touch. So now the next thing is what, how we can detect charge with the help of this electroscope. So this is uncharged electroscope, everyone. Now we want to detect charge with the help of this electroscope. So we will take one rod here. You can see it here, we have one charge rod, and on this charge rod we have negative charge, correct? So when we will touch this negatively charged rod with this brass disc, then what will happen? Here some positive and negative charge both are present, correct? So on the negative charge, repulsive force will act, correct? Always negative charge are moving. So due to the repulsion, negative charge will move, and this negative charge accumulate over here, and positive charge is here, everyone. So now at the bottom part we have negative charge. So initially what is happening, these leaves are closed, everyone, it is converse, and when we will touch, correct, with the rod, and on the rod we have negative charge. So what will happen on this conductor also we have negative positive charge, so negative charge will repel and it will accumulate over here. So now between negative negative we have repulsive force, and now it will diverge, correct? So when it is diverging, so means here some charge is present, that's why it is diverging, because when it is diverging, so here is negative charge, and between this negative charge repulsion is happening, that's why the divergence is happening. Same thing you can do it with a positive rod also, but when you are, when if you have a positive rod, then what will happen? Let's see it, everyone. Let's suppose it's a positive rod, and if you touch the positive rod with this brass disc, then what will happen? Then what will happen, everyone? This positive charge rod attract the electron. So now at the top part we have electron, and the bottom part we have positive charge, and here we have negative charge. So this thing will happen. So again it will diverge. So if you will put near negatively charged rod or positively charged rod, in both cases this leaf will diverge, everyone. So like this we can detect charges with the help of this gold leaf electroscope. So I hope this thing is clear to everyone, how this gold leaf electroscope is working. Now next we will discuss about Coulomb's law. So what is the Coulomb's law, everyone? The magnitude of electrostatic force between 2 point charges is directly proportional to the product of charges and inversely proportional to the square of separation distance between them. So according to Coulomb's law, electrostatic force between two charges is directly proportional to the product of charges and inversely proportional to the square of distance. Now, if we combine this both, then we will get electrostatic force Q1 Q2 by R square. This is electrostatic force, correct? So if you will combine these both things, everyone, now we have this equation F is directly proportional to Q1 Q2 by R square. Now remove this proportionality sign. So if we will remove proportionality sign, then we have one constant, and this constant is known as Coulomb constant, everyone, and we are representing this constant with a small k letter. So k q1 q2 by r square. This is the electrostatic force between these two charges, and these two charges is present at r distance. Okay, so force acting on the first charge due to the second. So F12 is representing here force on the first charge due to the second, and F21 is representing here force on the second charge due to the first, correct? And this both are action reaction pair, everyone. According to Newton's third law, always forces are acting in the pair. So this F12 and F21 both are action reaction pair, so magnitude of force should be same. So F12 and F12 and F21 both are equal, everyone, but the direction is opposite. So this thing already we know that how action reaction pair are working, correct? So note down this thing. Let's see next slide, everyone. So about the k, already we know that it is the proportionality constant, and k can be written as 1 upon 4 pi em, correct? Where em is what? It is the permittivity of the medium. So let's suppose we have two charges q1 and q2, and separation between the charges is r, and between these two charges we have free space, correct? So we have free space, everyone, between these two charges. So if between these two charges we have free space, then permittivity of the medium is equal to the permittivity of the free space, means em is equal to e naught, everyone, correct? Epsilon m is equal to epsilon naught. This thing we can write down. So now k value will become 1 upon 4 pi epsilon naught. And what is the value of permittivity of the free space, everyone? It is 8.85 into 10 raised to minus 12 in SI unit, correct? So in the SI unit, permittivity of the free space can be written as 8.85 into 10 raised to minus 12. If you will put this value here, 8.854, and pi is 3.14, and then we will simplify. Then k you will get 9 into 10 raised to 9 in SI unit. So the value of the k for the free space is 9 into 10 raised to 9, and it is different for the different medium. If we will put these two charges in the water or in the kerosene, so force between these two charges will get changed. And why it is getting changed? Because of that here permittivity of the free space is different, correct? Permittivity of the medium is different. That's why here force between charges will get changed. But this thing will not happen with a gravitational force, because in the gravitational force we have there capital G, and G is the universal constant, and everywhere in this universe this G value will remain the same. So G is not depending on the medium, it is universal constant, so everywhere it is the same. That's why gravitational force between these two charges will remain the same, but electrostatic force will get changed because electrostatic force is depending on the medium. So I hope this thing is clear to you. Now the next thing is what? Permittivity. What is the sense of the permittivity? So permittivity is related with the permit, everyone, correct? So it is related with the permit. So permittivity is measure how well the material allow the electric field to pass through it, represented by the symbol epsilon. So some material from some material electric field is passing easily, but from the some material electric field is not passing easily. It is feeling some difficulty, correct, when the electric field is passing through the material. So from the some material electric field is passing easily, so permittivity of that material is what? It is different, correct? So for the different material we have different permittivity, because with the help of permittivity we are measuring how well the material is allowed the electric field to pass through it, correct? And it is related with the permit. So I hope this thing is clear to you. Now we will discuss about the characteristics of the electrostatic force. So see it, first characteristic, everyone. Electrostatic force can behave like a central force. So what is the sense of the central force? How we can represent? Let's suppose we have two charges, Q1 and Q2. This Q1 and Q2 charges present at some distance r. Now make it here center of the charge. Let's suppose this is center of charge for the first charge and this is center of charge for the second charge. Now we want to make it line joining, correct? So if you want to make the line joining, then what we can do it, connect this center to center. So this is the line joining of these two charges. So central force is always present along this line joining, everyone. This is the sense of the central force. Gravitational force is also central force because gravitational force is also present along this line joining. Now let's see next point. Electrostatic force form an action reaction pair. So always we know this thing, forces are acting always in the pair, correct, according to Newton's third law. So electrostatic force is what? It is the action reaction pair. Now the third point is the strength of the electrostatic force between two charges depend on the medium in which they are placed. So we know that this thing, electrostatics force formula is what? It is K Q1 Q2 by R square. And what is the value of K? It is 1 upon 4 pi EM, correct? This is the value of K. EM is what? It is the permittivity, correct? And this permittivity value is depending on the medium. So for the different medium, EM value is different. So definitely K value is different for the different medium. That's why electrostatic force is depending on the medium. But the gravitational force is not depending on the medium. So I hope this all 3 points are clear to everyone. Now next we will discuss about the limitation of the Coulomb's law. So let's see it. First limitation, everyone. This Coulomb law is only valid for the static charge. Charge should be static, everyone. Let's suppose we have two charges and this both charges is moving in same direction with VV speed. So we have two charges, this both charges are moving with VV velocity, correct, in this direction. Now we want to find out how much force is acting between these two charges. So in between these two charges we have electrostatic force. They will repel to each other, correct? But when they are moving, then around this charge we have magnetic field is also, correct? We have magnetic field also around this charges. And when charges is present in the magnetic field, so on the charged particle we have magnetic force also. So that's why this Coulomb's law is only valid for the static force. If we are applying this Coulomb's law for the moving charge particle, then we have to add here magnetic force also. That's why. Now the second point is what here? Difficult to apply the conductive material. See it. Coulomb's law is only valid for the point charges, correct? And if we are taking the conductive material, so conductive material has some volume also, like we have two charges. And now this is not a point charge, this both charges has some volume. Let's suppose this is the positive charge present on the A and on the B also we have positive charge. So when we are putting this both at some distance, so what will happen? The positive will repel to each other. So now the center of charge will shift. Now the center of charge will shift, everyone. Now the center of charge is here on A and the center of charge on B is here. So now it is shifting. So we can see it here. We don't know here where the center of charge is present. Exactly where the center of charge is present, this thing we don't know. And when we are putting near to each other, then center of charge is shifting also. So when it is shifting, then the center of charge is shifting, then we don't know what is the r distance, correct? So if we don't know r distance, so how we can find out electrostatic force? Because electrostatic force is depending on the distance between the charges. we have electrostatic force formula is F equal to K Q1 Q2 by R square, where R is what? It is the distance between the charges. So here we don't know R, so that's why we don't know electrostatic force also. So I hope these both points are clear to everyone, why it is difficult to apply on the conductive material, because it is difficult to find the center of charge for the conductive material. That's why it is difficult. Let's see this question, everyone. 2-point charges A and B having charge plus Q and minus Q respectively are placed at a certain distance apart, and force acting them is F. If 25% charge of A is transferred to B, then force between the charges become. So here we have four options, everyone, and we want to determine which one is correct here. So let's see how we can do this question. We have 2-point charges A and B. So let's suppose this is A and this is B. 2-point charges A and B having charges plus Q and minus Q respectively are placed at a certain distance apart, and force acting them is F. So let's suppose this both charges is present at R distance initially. So between these two charges we have F force. So according to Coulomb's law, force can be written as K Q square by R square. There is a force between these two charges. Now what we are doing, if 25% charge of A is transferred to B, then force between the charges becomes. So we are transferring 25% charge from A to B. So 25% charge we are transferring. 25% of Q is what? It is Q by 4. So 25% charge of A is transferred to the B. So now on A we have total charge plus Q minus Q by 4, because we are transferring this much charge. So remaining charge on the A is what? Is Q minus Q by 4, and on the B we have minus Q plus Q by 4. Correct? So charge present on the A is what? 3Q by 4, and here we have minus 3Q by 4. There is a charge on A and B. Now new electrostatic force between these two charges is K, charge is 3Q by 4 into 3Q by 4. Correct? I am doing here square divided by distance between the charges. We are not changing here. Again it is R only. So distance is same here. It is again R. So F dash is equal to what? It is K 3Q by 4 whole square divided by R square. Now if you will simplify this, then we have F dash is equal to 9K Q square by 16R square. So KQ square by R square is what? It is a F, everyone. So F dash is equal to what? It is F dash equal to 9 by 16 F. This is the F dash value. So what is the new force? It is 9 by 16 F, and if you will check your option, then we are getting option B. So B is the correct answer, everyone, here, 9F by 16. Let's see next question, everyone. Two pitch balls carrying equal charges are suspended from the common point by a string of equal length. The equilibrium separation between them is R. Now the string are rigidly clamped at the half the height. The equilibrium separation between the balls now become. So here we have two balls, everyone, and equal charges present on this ball. So let's suppose charge present on this ball is Q, and height of the clamp is right here in the first case number 1, and in the case second, clamping height is y by 2, correct, and separation between the charges is, let's suppose now it is r dash. This is r dash. So if I will make FBD of this first charge, so how many forces acting on this Q charge? So first of all, we have here electrostatic force, correct, Fe. In downward direction, we have gravitational force. Let's suppose mass of the particle is m, so gravitational force is mg, and tension in this string is T, and this angle is theta here, everyone. Now if this angle is theta, and if I will draw here one vertical line, so this angle is also theta. So this angle is theta, so this angle is also theta. Now see it here, everyone. On this charge in downward direction, we have gravitational force. In this direction, we have electrostatic force. And then we have tension force T. And this angle is theta. So if I will resolve this tension force in horizontal and vertical direction, so this is T cos theta, and this is T sin theta. Now T cos theta is equal to mg, and T sin theta equal to Fe. Correct? Take ratio of this both equations. This is equation number 1 and this is equation number 2. So if I will take the ratio, then T will get cancelled out, and we have 10 theta equal to Fe by mg. And here Fe is what? It is the electrostatic force. So 10 theta is equal to Fe by mg. Fe can be written as K Q square by R square mg. Now what is the 10 theta value? If we will look the geometry, so from the geometry 10 theta can be written as perpendicular by base. So perpendicular is what? It is R by 2, correct, and length of base is y. Okay, so this is equation number 3rd, and this is equation number 4th. So from 3rd and 4th, what we will get, if we will equate K Q square by R square mg equal to R by 2y, correct? This thing we have. Now the next thing is what? R square, if I will put on this side, so we have what? K Q square 2y divided by mg equal to R cube. This thing we have. Now the next thing is what? Here this relation we are getting, we can see it here, K Q square to m and g. These both are constant in both the cases. So we can say that R cube is directly proportional to y. This thing we can say, correct? So if you will use this relation for the case 1 and case 2, so it can be written as R1 cube by R2 cube equal to y1 by y2. So R1 cube is what it is, R1 equal to what it is, R everywhere, and R2 we don't know. So write down here R dash cube, or we can write down R2 cube also. We are finding this. And what is the y1? It is y. And what is the y2? It is y by 2. So y by will get cancelled out. We are getting 2 here. So now next thing is R cube by R2 cube. equal to 2 R2 cube equal to RQ by 2. So R2 equal to R by 2 power 1 by 3. This is R2 value. So finally we are getting separation between these two charges is R2 equal to R by 2 power 1 by 3, and R2 is equal to what it is, R dash, everyone. So R2 is what it is, R dash. So I hope this thing is clear to everyone, how we can do it this question. So if the clamping at half of the height, then the equilibrium separation between the ball is this, everyone, R by 2 power 1 by 3. Let's see next question, everyone. Two identical charge spheres suspended from the common point by two massless string of length L are initially a distance d. D is very less as compared to the L, apart because of their mutual repulsion. The charge being to leak from both the sphere at a constant rate. As a result, the charge approaches each other with a velocity v, then as a function of distance x between them. So in this question, we want here relation between velocity and x, everyone. Between v and x, we want relation here. So let's see how we can do it. So first of all, we have string. And let's suppose the initial distance between these two charges is d here. And charge is q dash on both the sphere. Correct? Now leakage of charge is happening here. So after some time, separation between the charges is becoming x here. And now they have some velocity also. And angle is theta here. So this angle is theta, everyone. And separation is x. And charge is q dash here on both the sphere. If I will make ABD of one charge, so let's see it, how it is looking. This angle is theta here. In downward direction, we have gravitational force mg. And here we have electrostatic force k q square by x square. And tension in this string is T here. Correct? Now resolve this. And if this angle is theta, everyone, so with the vertical, so we have theta angle. Correct? So if I will resolve the T along this direction, in the vertical direction, so this component should be what? It should be T cos theta. And this component should be what? It should be T sin theta. Correct? And here, this mg should be equal to T sin theta. This is T sin theta, everyone. This is T cos theta, the vertical. So T cos theta equal to mg. This is equation number 1. And k q square by x square equal to T sin theta. Now take ratio of this both, then you will get tan theta equal to k q square by mg x square. This thing we will get. And if you will look this geometry, everyone, from the geometry, because distance from here to here is x by 2, this is tan theta. So tan theta is what is the perpendicular by base. Correct? but base length we don't know. We know this length is L here, but here one condition is given: D is very less as compared to L. If D is very small as compared to L, so theta is very small. Theta is very small. So if theta is very small, then sine theta approximately equal to tan theta. Then sine theta is equal to what? It is perpendicular by base, means it is x by 2l. So sine theta is what? It is x by 2l, and it is equal to tan theta. So this value we will put here, x by 2l equal to kq square by mg x square. Now this is xq, everyone. This is xq divided by kq square 2l divided by mg. Now if you will look this kq square 2l mg, correct? So this k 2l mg, this all things are constant, only q is varying here because leakage of charge is happening here. So finally what we can do it here, what we can write down, xq is directly proportional to q square. This thing we have. So we have xq is directly proportional to q square, and this thing can be written as like this also: q is directly proportional to x power 3 by 2. Now do it differentiation of this. So dq by dt is directly proportional to 3 by 2 x 3 by 2 minus 1, and differentiation of x with respect to time is dx by dt. So dq by dt is what? Because it is constant, it is given in this question. If you will read this question, everyone, clearly it is written: the charge being to leak from both the sphere at a constant rate. So rate is constant, everyone. Leakage of charge is happening with a constant rate. Dq by dt is constant according to the question. So dq by dt is constant here. This is constant. 3 by 2 is constant. Dx by dt is v. So here we are getting here, and this is x power 3 by 2 minus 1. So if we will simplify 3 by 2 minus 1, so it is 1 by 2, and it will go on the left side. So it is v is directly proportional to x power minus 1 by 2 after simplification of this. So finally we are getting velocity directly proportional to x power minus 1 by 3. Now if you will check here option, then which options we are getting? We are getting option number A. A is the correct answer for this question. Let's see next question, everyone. A system of two bodies A and B of mass 2 kg and 4 kg respectively have equal charges 2 coulomb on them. Find the speed of A at t second if the speed of B is 20 meter per second at that instant. Take the system to be at rest initially. So let's see how we can do this question, everyone. We have two bodies A and B. And the mass of A is what? It is 2 kg. And mass of B is 4 kg. Between these two, because on this both bodies we have equal charges, 2 coulomb. So due to this, what is happening? Between these two charges we have repulsive force. They are repelling to each other. So due to this repulsive force, they are accelerating. That's why they are getting some velocity also. So initially the system in the rest condition, so initial velocity is 0. But at t time, what will happen? At t time, at t equal to t time, let's suppose this particle is here and this particle is here, and velocity of A is we don't know, we want to find out velocity of A at this t time. But velocity of B we knows. Velocity of B is what? It is 20 meter per second. Correct? So if you will observe this system, everyone, on this system, external force is not present. So on this system, external force is zero. So on this system, external force is zero. That's why momentum should be conserved. Correct? So if external force is zero, so momentum should be conserved. Means initial momentum should be equal to final momentum. This thing we knows. So initial momentum should be equal to final momentum. Initial momentum is zero because velocity of the system is zero. And what is the final momentum? It is the mass of the A, velocity of the A plus mass of the B and velocity of the B. So mass of the A is how much, everyone? It is 2. And velocity of A we don't know. Mass of the B is 4 kg and the velocity of the B is 20. So velocity of A is equal to what it is? Minus 4 into 20 divided by 2. So it is minus 40 meter per second. This is the velocity of the A. So velocity of A body is what? It is minus 40 meter per second after t time. So I hope this question is clear to you.